Welcome back. We are covering part 2 of 2.3, and we are covering increasing, decreasing intervals, and local maximums and minimums. Okay, so here we have this graph, and one of the things we become concerned about with the graph is where that graph is increasing, where that graph is decreasing. And just like back when you had lines, you looked at the slope and you looked at whether or not the slope was positive, and if you're walking left to right, and you had this here. Hold on a second. That looks bad. Let me get that one. So if you were walking left to right and you had a line like this here would have a positive slope, and then if it started to go like this, you would be going downhill, and so this would have a negative slope, right? Okay, so same thing here. We want to know where is it, you can think of it as where is it positive, where is it increasing, and which way is it decreasing. So one thing students might get thrown off with is this arrow here. Don't try to ignore that. That just means it goes on forever, right? Okay, but we want to know what's happening with the graph as you look at it from left to right, just like the lines. If you're going uphill, that's positive slope. If you're going downhill, that's negative slope. So you can think of this maybe as a roller coaster, okay? And you are in it. Let me draw your head here. And you're like, woo, look at me. Those are your hands. Okay. And that's your face. Okay, anyway. And you're going that way. So what happens is as you ride this roller coaster, you start going downhill and then experiencing some G-forces here. Okay, so you go downhill and then all of a sudden you turn and you start going up, and then you come back down, and then you go back up, and you go back down, right? So that is essentially what we mean by increasing and decreasing intervals. Okay, so here you would be going down, so that would be a decreasing interval. This would be an increasing interval. This would be a decreasing interval. And then from here to there would be increasing and then decreasing. Okay, so we want to be able to label those intervals of decrease and increase. Okay, so let's start with over here. Okay, so let's just go ahead and start with the decreasing. Okay, so here, the intervals where our function is decreasing would be from, so this is your roller coaster, you would be going down, and so you would be going down from negative infinity all the way up to, I guess this is negative 6, okay? So negative infinity to negative 6. And all of these intervals of increasing and decreasing are going to be open intervals. So you don't have to worry about, oh, do I do a bracket? That's for those less than equals, okay? But here they're all going to be open intervals. All right, so that's not the only place where you would be going down on the roller coaster. You would be going up here. So here's a spot where you would be going down from here to here, and that is from 8 all the way to 16. So a decrease on this ride from 8 to 16. Okay. And we have one more interval where you would be going downward, and that would be here from 24 all the way downward. Okay, so to positive infinity. Okay, so when you write your intervals, just keep in mind that these are all based on x values. Okay, so you say from this x value to that x value. Okay, so from this x value 8 to this x value, 16. Okay. All right, and let's go ahead and take a look at the interval, also based on the x values. Okay, your intervals where you are going upward, increasing. So, went down on the roller coaster, and now you're going up. So you are going up on this interval right here, which is from -6 to +8. -6 to +8, you are going upward. So -6 to +8, you're going upward, and then you go down, and then you go back up from 16 to 24. 16 to 24. And that looks like the only intervals where you are going upward, right? Down, up, down, up, down. Okay. All right. So why don't you go ahead and give this one a try. Go ahead and list your intervals where you are decreasing. And go ahead and list your intervals where you are increasing. Okay. So go ahead and hit the pause button and see if you get the same answers that I get. All right, so again, if you are riding in a roller coaster, right? All right, that's you riding in a roller coaster. And then you would be going down. So down, up, down, up, down, up. Okay, so we start off down. So down from -infinity to -17. And then up, and then down here, from here to here. So that's from -6 to 4. And then we go up and then back down right here from 9 to 13. 9 to 13. That looks like that's about it. Okay, and then increasing. All right, so you are increasing. So this is down and then up. So up from -17 to -6. Okay, so down, up, and then down, up again. From here to here, you're going upward. So from 4 to 9. 4 to 9. You're going upwards. So 4 to 9, you're going up, and then down, and then back up again. So back up again, starting from 13 to +infinity. Okay, and those would be all of the intervals. Okay, so that's increasing and decreasing, pretty straightforward. Okay, so again, just make sure you're using x values to describe those intervals. Okay, that's how I'm getting these numbers. These are all x values. From what x value to what x value are you going up? From this x value to that x value, from this x value to that x value. Okay, so these increasing intervals are your intervals. Sorry, somebody's knocking at the door. Okay. All right, so let's go ahead and let's do local maximums and minimums. Okay, so what happens here is we also become, in math, we become concerned about what's happening right around these areas where the graph starts to transition from decreasing to increasing, or right here when it transitions from increasing to decreasing. Okay, so those areas, these little neighborhoods where those are happening, contain these points that we call maximums and minimums. And so, so here we can see that this here, we hit this low point, right? So in our graph, we hit this low point, and then we go up, and then we hit this sort of peak, this high point, and then we drop again, and we hit this low point, and then we hit this high point, and we come back around, right? Okay, so these are our local maximums and minimums. So these here, these high points, are our local maximums, and these low points here are our local minimums. And we say local because even though this is a minimum and so is this, even though this is not lower than that one, this is still considered a minimum, and this is considered a minimum. Even if there's a number here, a point over here that's even lower, right? So these local maximums and minimums are these sort of points of transitions, these turnaround points, okay, where it goes from decreasing to increasing, or from increasing to decreasing, okay? So that if we look at just that little neighborhood, then yeah, if I draw a little circle around here, then yeah, and I ignore the rest of the graph and I just zero in on this tiny little neighborhood around this point, then yeah, that would be the highest point, right, in this neighborhood. Same thing here. If I drew a little circle around this point right here, then yeah, that would be the lowest point in this neighborhood. Okay, so that would be a minimum, local minimum. Same thing here. If I drew a circle around here, that point would be the highest point in this little neighborhood. Okay, so that's what we're doing. We're looking at these little neighborhoods at these points of transitions, and those are called our local maximums and minimums. Okay, all right, so we can see here that our this year our maximums here is 50, the maximum y value. Here the local maximum would be 50, and here the lowest point would be 32. Here it would be 20. Okay. All right, so let's start off with a formal definition here. Okay, so let me see if I have room. Yes. Okay, so local maxima and minima. So local maxima and minima. Okay. So here, the function value, f of a is a local max value of the function f if f of a is greater than or equal to f of x for all x near a. So that's what I mean by when they say for all x near a, that's when I'm talking about that. Oh, if I do a little neighborhood, then for all the points that are in this little neighborhood, that one is the largest y value. Okay, so 50 would be a local max. Okay, so over here, the local max would be 50. Because they're both 50. If this had said 52, then we would say, oh, it would be 50 and 52. But it's 50 and 50, which is the same number. Okay. Okay, and then our formal definition for local minimum. Okay, so the function value f of a remember f of a is a y value, okay, is a local minimum value of the function f if this y value is less than or equal to f of x for all x near a. So again, that little neighborhood. Okay, like this. So if I drew a little neighborhood, all the x around it, this one has the smallest y value. Okay, so over here, we have minimums at, we have a minimum 20 and 32. Okay, so 20 is a minimum value and 32 is a minimum value. Okay, all right, so go ahead and try this one. See if you can locate the maximum and the local min. Okay, and remember these are y values. Okay, so go ahead and hit the pause button. All right, so maximums are the high points, like here, like the peaks, the peak of the roller coaster. Peak, peak. Okay, so here, we have a max, and here we have a max. So 5 and -7. That looks like a point, so let me just spell it out. 5 and -7. Okay, minimum, so low points. Here you have a min, here you have a minimum, and here you have a minimum. Okay, and again, they're the y values. So -8 and -10 and -19. So those would be your local max and min. I believe that is it. Okay, so if you have any questions about this, make sure you email me or text me, or you can go to the Math Study Center and meet with our tutor, and or any tutor really, and they will help you.